Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. And my name is Associate Professor Dr. Mak Muazi. In this video is a continuation from the 3.19 contact stress. In the subtopic of contact stress uh, is a subtopic is called spherical contact stress. Okay. In the textbook from Shikli Mechanical Engineering Design textbook, you can find these figures. Okay, these figures. You see the ball here. You see the two balls, one small and one big. Okay. Uh, it is imagine. You can imagine the contact stress happen like that lah. It's called the topic is called spherical contact stress. You can imagine a ball bearing. Okay, you can imagine a ball bearing. This ball bearing, when you see from this view, it is like a circle. Okay. The place that is in contact, this is called spherical contact stress lah. Okay. So you can see the equation given here is also from the textbook. Okay, formation of contact stress when two spheres with diameters D1 and D2 are pressed together under force F, a circular contact area forms at the point of contact. Elastic properties influence the contact radius. Elastic properties E1 V1 for sphere 1 and E2 V2 of the contact area based on material response to compressive load. Okay, it is used for high load applications for steel spheres under moderate force. This small contact region bears high loads, crucial for application like ball bearings where durability is the key. Okay. So, elastic properties, if you remember the material chapter that we have discussed in the previous videos, okay, everything has the elastic region, meaning that it will come back into its original position. Okay, ball bearing, okay, this ball bearing usually is a metal ball bearing. Okay, it is in contact. Okay, when it's contact, as long as it doesn't break, doesn't damage, it will be in elastic properties, meaning that it will come back to its original position. Okay. So pressure distribution in contact area, hemispherical pressure profile. The pressure distributed across the contact area is hemispherical with peak pressure at the center, diminishing towards the edges. Okay. So you can imagine this ball bearing like here. The right picture, like it depicted that in 2A in the right picture. Okay. The pressure is large on the contact surface, and uh, left and right to the contact surface, the pressure become diminishes. Okay. So maximum pressure formula, the peak pressure Pmax is given by Pmax equal to 3F over 2 pi A power of 2, where it scales with applied force and contact surface. Impact on wear and durability. Understanding pressure distribution is essential in design of to minimize wear, as high contact pressures can lead to material degradation over time. Okay. So we want to avoid too much contact. Okay. That's why we put lubricant and everything, so that the contact of metal to metal contact will be very minimum, so we can use that part for a long time. Okay. So maximum stress location, principal stress 1 and 2 along the z-axis reach their peak at the contact point between the spheres. Okay, stress component. Principal stress are key for understanding how material resists deformation under compression and are expressed as sigma 1 and sigma 2 and sigma 3. The application in high bearing design, high z-axis stress inform the design of bearings and other components that need to resist high compressive force without falling. Okay. Why is Z axis? Okay, you know imagine the three-dimensional axis X, Y, and Z. Okay, like depicted by my finger here. You can imagine Z X axis, Y axis where, and the Z axis is the going down. Z axis in this case is going down. Okay, meaning that the force is it just want to say that the force is axial force going down. Okay, that is the Z axis. Z. Okay. And then stress and surface fatigue, shear stress distribution, shear stress peaks slightly below the surface in the contact area, which can lead to fatigue and crack formation. Impact on material fatigue. Surface fatigue or failure occurs when stress cycles cause macro cracks, eventually propagating to the surface. Application in rotary machine. In components like gears and rollers, understanding the shear stress distribution helps engineers prevent premature surface failure. Okay, so this is what the purpose that we learn this subject lah. Okay, okay. So I think that's all for the video right now. Inshallah we meet in the next video. Thank you very much.